The universe has a way of humbling us every time we think we've unraveled its secrets. It throws something at us so bizarre, so utterly inexplicable, that it forces us to question everything we thought we knew. Picture this: you're gazing up at the night sky, tracing the familiar constellations, when suddenly, a pulse of energy streaks across the cosmos, a signal so powerful it outshines entire galaxies, yet lasts only milliseconds. No warning, no explanation, just a fleeting cosmic whisper that leaves astronomers scrambling for answers. This isn't science fiction. These are real cosmic anomalies, the universe's way of reminding us that the rules we've written might just be scribbles in the margins of a much grander, stranger story. What if I told you there are places in space where time seems to warp, where galaxies spin in ways that defy gravity's grip, or where invisible forces tug at the fabric of reality itself? These aren't plot twists from a sci-fi novel. They're genuine mysteries etched into the cosmos, waiting to be decoded. Some of these enigmas are so perplexing that even Einstein's equations stumble when trying to explain them. Take, for example, the eerie void where nothing, not a single star, not a wisp of gas exists for hundreds of millions of light years, or the celestial objects that move faster than physics should allow, as if the universe itself forgot to hit the brakes. These aren't just curiosities, they're cosmic rebellions, challenges to our understanding whispered across the vastness of space. So why should we care about these distant, otherworldly puzzles? Because they're more than just celestial oddities, they're clues. Every time the universe defies expectations, it's handing us a piece of a puzzle that could rewrite textbooks, redefine reality, or even reveal entirely new laws of physics. And that's exactly what we're diving into today. 20 of the most mind-bending cosmic anomalies that leave scientists staring at their data in disbelief. From rogue black holes wandering the cosmos like interstellar ghosts to mysterious radio bursts that repeat with eerie precision, each one of these phenomena is a doorway into the unknown. So buckle up, because by the end of this journey, you'll never look at the night sky the same way again. One summer night in 1977, a radio telescope at Ohio State University picked up something extraordinary, a burst of radio waves so intense, so perfectly tuned to a frequency where cosmic noise is minimal, that the astronomer who discovered it circled the data on his printout and wrote one word in the margin: "Wow." That single word gave the signal its name, but it also captured the sheer astonishment of stumbling across something that shouldn't or couldn't exist. For 72 seconds, this narrowband signal blazed from the direction of the Sagittarius constellation, then vanished without a trace. No natural cosmic phenomenon we know of, no pulsar, no quasar, no stellar flare matches its profile. It was as if the universe had leaned in and whispered a secret, only to disappear before we could ask what it meant. What makes the wow signal so tantalizing isn't just its strangeness, but its eerie precision. The frequency it used, 1420 MHz, is a cosmic dead zone, a quiet channel where hydrogen, the most common element in the universe, naturally emits radio waves. It's also a frequency scientists once speculated advanced civilizations might use to broadcast their presence, a sort of interstellar hailing frequency. And yet, despite decades of searching, we've never heard anything like it again. Was it a fleeting glitch, a cosmic coincidence, or could it have been what some daring researchers suspect, a deliberate beacon, a single, unread message from a civilization far beyond our own? The mystery deepens when you consider the signal's structure. Unlike the chaotic bursts from dying stars or colliding black holes, the wow signal was clean, narrow, and focused, almost engineered. It followed the exact pattern you'd expect if someone were deliberately aiming a transmitter at Earth, rising and falling in intensity as the telescope's antenna swept across the sky. Yet no known natural phenomenon behaves this way. Even more puzzling, subsequent scans of the same region found nothing. No repeating signal, no residual traces, just silence. It's as if whatever sent it flickered into existence for one brief moment, then dissolved back into the void. Skeptics have proposed theories: a passing comet reflecting radio waves, an undiscovered astrophysical event, but none fully explain the signal's bizarre characteristics. And so, the wow signal remains astronomy's ultimate cold case, a cosmic flare that defies categorization. It's a reminder that for all our technology, for all our theories, the universe still holds cards it hasn't shown us. Whether it was a natural oddity or something more profound, one thing is certain: that 72-second burst shook our assumptions about the cosmos, and the question it left behind still echoes. If it was a message, who or what was on the other end? And if it wasn't, what in the universe could possibly make a sound like that? Now imagine a universe where everything you can see, the stars, the planets, even your own hands, makes up less than 5% of what's actually out there. The rest, a shadowy, invisible force called dark matter, a cosmic phantom that doesn't emit light, doesn't reflect it, and doesn't interact with ordinary matter in any way we can detect. Yet its presence is undeniable. Picture a merry-go-round spinning so fast that the children clinging to it should be flung into the air, but instead, they stay glued in place, as if unseen hands are holding them down. That's exactly what dark matter does to galaxies. Without it, stars on the outer edges of spiral galaxies would fly off into the void, their motion defying the laws of gravity as we understand them. So how do we know it's there? The clues are written in the bends and warps of space itself. When astronomers peer at distant galaxies, they often see their light stretched and distorted, as if passing through a giant, invisible lens. This phenomenon, called gravitational lensing, reveals the presence of massive, unseen structures, dark matter, curving the fabric of space-time like a hidden hand pressing down on a trampoline. Even more baffling, simulations of the universe's evolution show that without dark matter's gravitational scaffolding, galaxies as we know them could never have formed. It's the universe's hidden architect, shaping everything from the largest galaxy clusters to the delicate dance of stars within them. Yet for all its influence, dark matter remains maddeningly elusive. Scientists have spent decades hunting for it, with detectors buried deep underground, in abandoned mines and beneath mountains, shielded from cosmic interference. They've looked for faint flashes of light, tiny bursts of heat, any sign that dark matter particles might occasionally bump into ordinary atoms. So far, nothing. The leading theory suggests dark matter could be made of WIMP, weakly interacting massive particles, hypothetical entities that barely acknowledge the existence of normal matter. But there are other possibilities, some even stranger. Could dark matter be tied to extra dimensions, particles from a parallel universe leaking into ours? Or might we need to rewrite gravity itself, as theories like modified Newtonian dynamics suggest? The irony is profound. The stuff that makes up most of the universe's matter is completely invisible to us, a cosmic joke played on our senses. Every time we think we're closing in on an answer, dark matter slips through our fingers like smoke. It's a reminder that the universe operates on rules we're only beginning to glimpse, and that the greatest mysteries aren't always written in the stars, but in the empty spaces between them. Until we crack this enigma, we're left with a universe where the majority of matter is, quite literally, hiding in plain sight. If you thought the wow signal was strange, wait until you hear about the cosmic fireworks known as fast radio bursts. Imagine a burst of energy so powerful that in just a fraction of a second, it releases more energy than the sun does in 80 years, then disappears without a trace. These fleeting flashes, detected as blips of radio waves from billions of light years away, have astronomers scratching their heads. Some explode once and vanish into the cosmic background noise. Others repeat on unpredictable schedules, like a celestial alarm clock with no rhyme or reason. What makes these bursts so baffling isn't just their intensity, it's their sheer unpredictability. Take FRB 1214, the first repeating fast radio burst ever discovered. Unlike its one-time counterparts, this one sends out sporadic pulses from a dwarf galaxy 3 billion light-years away, sometimes firing off multiple bursts in an hour, then falling silent for months. Even stranger, some bursts arrive with a telltale twist in their radio waves, suggesting they've passed through incredibly strong magnetic fields like those near a neutron star, or perhaps something even more exotic. Theories abound, but none fully explain the phenomenon. Could these bursts be the death cries of neutron stars collapsing into black holes, the shock waves from cosmic strings, hypothetical defects in spacetime itself? Or, as some have daringly suggested, might they be evidence of advanced civilizations harnessing unimaginable energy to power interstellar light sails? One thing's certain, every new detection adds another layer to the mystery. In 2020, astronomers observed an FRB originating inside our own Milky Way for the first time, linked to a highly magnetized neutron star called a magnetar. While this discovery provided a potential clue, it only deepened the puzzle. Most FRBs come from galaxies far beyond our own, and their energies dwarf anything a magnetar could produce. The real enigma lies in their staggering distances. To reach us with such clarity across billions of light years, these bursts must be amplified by something: cosmic lenses, interstellar plasma, or processes we haven't even dreamed of yet. And with new FRBs being detected almost weekly, each one seems to defy expectations in its own way. Some arrive with a rhythmic precision, like cosmic Morse code. Others scatter their signals in chaotic splashes of energy. It's as if the universe is testing us, throwing increasingly bizarre variations into the mix just when we think we're closing in on an answer. What's thrilling is that we're witnessing this mystery unfold in real time. With every new telescope, like Canada's CHIME array, which scans the entire northern sky daily, we're catching more of these elusive bursts, piecing together fragments of a puzzle that might rewrite our understanding of high-energy astrophysics. Whether they're natural cosmic accidents or something far more extraordinary, fast radio bursts remind us that the universe is still full of voices we're only beginning to hear. And until we decode their origin, they'll remain one of space's most electrifying unsolved riddles. Somewhere in the depths of space, an invisible hand is tugging at our galaxy, along with hundreds of thousands of others, with the gravitational pull of something so massive, it warps the very fabric of the cosmos around it. Astronomers call it the Great Attractor, and it's one of the most unsettling mysteries in modern astrophysics. Picture floating down a river, only to realize the current isn't just carrying you, it's dragging everything around you toward a waterfall hidden by an impenetrable fog. That's the Milky Way's reality right now, as we hurtle toward this enigmatic region at over 2 million kilometers per hour, with no clear idea what's pulling us in. For decades, the Great Attractor's secrets were locked away behind what astronomers poetically call the zone of avoidance. a thick shroud of dust and stars at the center of our own galaxy that blocks our view of the cosmos beyond. It's like trying to peer through a sandstorm to spot a distant mountain, but with infrared telescopes and radio astronomy, we've begun piercing that veil, revealing hints of something colossal lurking in the darkness. What we've found only deepens the intrigue. The attractor isn't just a single object, it's part of an even vaster structure called Laniakea, a supercluster of galaxies spanning 500 million light-years, where entire galaxy clusters flow like rivers toward a gravitational epicenter. Yet here's the twist: even Laniakea's immense mass can't fully account for the pull we're experiencing. There's something else, something beyond our current maps of the universe, adding to this cosmic tug-of-war. Some scientists speculate it could be a concentration of dark matter so dense it bends spacetime like a bowling ball on a trampoline. Others wonder if the Great Attractor is just the visible tip of an even larger structure, a shadowy network of galaxies and dark energy weaving a web we've only begun to trace. The most tantalizing clue came from observations of galaxies near the attractor, their motions suggesting the presence of a previously unknown cluster, dubbed the Norma cluster. But here's the catch: while massive, it's still not enough to explain the sheer scale of the gravitational anomaly. It's as if we've found a footprint, but the creature that left it remains just out of sight. This gravitational puzzle forces us to confront a humbling possibility, that what we perceive as the center of this cosmic pull might actually be a waypoint, a stepping stone to something even grander and more mysterious lurking deeper in the cosmic dark. What makes the Great Attractor so unnerving isn't just its invisibility, it's the way it challenges our place in the universe. We're not stationary observers, we're caught in a flow, passengers on a galactic conveyor belt heading toward an unknown destination. And until we unravel its secrets, this colossal enigma will keep reminding us that the universe is far stranger and far more dynamic than we ever imagined. In the constellation Cygnus, a star behaves like no other, flickering erratically, sometimes plunging into shadow with no warning, as if something vast and unseen is passing in front of it. Meet Tabby Star, officially catalogued as KIC 8462852, a cosmic enigma that's baffled astronomers since its discovery in 2015. This isn't the gentle, rhythmic dimming of a planet orbiting its sun. This is a star that occasionally drops in brightness by a staggering 22%, as if a celestial hand were turning a dial. At first, the explanation seemed almost too wild to consider. Could this be evidence of an alien megastructure, a vast energy-harvesting Dyson sphere built by an advanced civilization? The idea captured imaginations, but the truth, as always, is far stranger than fiction. The real mystery lies in the star's irregular dimming pattern. Most stars with planets exhibit predictable, periodic dips in brightness, a telltale sign of an orbiting world crossing their face. But Tabby Star dims at random intervals, sometimes for days, sometimes for weeks, with no discernible rhythm. Even more puzzling, historical data revealed something astonishing. Over the past century, the star's overall brightness has gradually faded by nearly 15%. Stars simply don't behave this way. They're cosmic furnaces, burning steadily for billions of years. So what could possibly cause such dramatic, chaotic changes? One leading theory points to vast clouds of dust, not the uniform rings around young stars, but swarms of debris, perhaps from a shattered planet or a colossal collision between asteroids. These uneven dust clouds could explain the erratic dimming, scattering starlight in unpredictable ways. Another possibility involves a family of giant comets, hundreds of times larger than Halley's Comet, trailing enough gas and dust to blot out the star's light intermittently. Yet even these explanations strain credibility. The scale of dust or comets required is almost unimaginable. Then there's the star itself. Tabby Star is an F-type main sequence star, slightly larger and hotter than our Sun, but otherwise unremarkable except for its bizarre light curve. Some researchers have proposed that the star might be consuming a nearby planet, its gravity tearing the world apart and creating a chaotic debris field. Others wonder if we're witnessing the aftermath of a cosmic cataclysm, like a moon crashing into a gas giant, scattering fragments into orbit. But here's the twist: every time a theory seems to fit, new data throws a wrench into the works. Observations from the Hubble Space Telescope revealed that the dimming affects some wavelengths of light more than others, a fingerprint that points to fine dust particles, not solid megastructures. Yet even this discovery raises new questions. Why is the dust so unevenly distributed? Why does the star's long-term fading defy all known models of stellar evolution? Tabby Star is more than just an astronomical oddity. It's a cosmic laboratory, challenging us to rethink how stars and their planetary systems behave. Every flicker, every dip in brightness is a clue, a piece of a puzzle we're only beginning to assemble. Whether it's dust, comets, or something even more exotic, one thing is clear: this star holds secrets that could rewrite our understanding of the universe's most fundamental processes. And until we solve its riddle, Tabby Star will keep us guessing, one unpredictable dimming at a time. There's a haunting silence in the cosmos, one that grows louder the more we learn about the universe. Consider this: with hundreds of billions of galaxies, each containing billions of stars, the sheer scale of existence suggests life should be everywhere. The math is undeniable, yet when we listen, when we search, all we hear is static. No signals, no artifacts, no cosmic neighbors waving back. This eerie disconnect is the heart of the Fermi Paradox, a puzzle so profound it forces us to confront whether we're alone or if something far darker is at play. The paradox takes its name from physicist Enrico Fermi, who, during a casual lunch conversation in 1950, posed a deceptively simple question: where is everybody? His point was razor-sharp. If intelligent life is common, even if only a fraction of civilizations develop interstellar travel, the Milky Way should have been colonized many times over by now. The fact that we see no evidence, no spacecraft, no megastructures, not even a single radio whisper, suggests something is profoundly wrong with our assumptions. Possible explanations range from the hopeful to the terrifying. Maybe we're the first. The universe is 13.8 billion years old, but Earth didn't form until 9 billion years later. It's possible we're early to the party, that intelligent life is still rare and scattered. Or perhaps civilizations inevitably hit a wall, a great filter, that prevents them from reaching the stars. This filter could be behind us, a fluke of evolution that made complex life on Earth miraculously unlikely, or ahead of us a looming catastrophe, like self-destruction through war or AI, that every advanced society fails to avoid. Then there's the zoo hypothesis, the idea that advanced civilizations know we're here but choose not to interfere, observing us like wildlife in a cosmic preserve. Or the dark forest theory, which paints a grimmer picture. In a universe where resources are finite, any civilization that reveals itself becomes a target. So everyone stays silent, hiding in the shadows, afraid to draw attention. The paradox grows even stranger when you consider the missing artifacts problem. Even if aliens never visit, their machines should. Self-replicating probes could explore every corner of the galaxy in a few million years, a blink in cosmic time. So where are they? Some suggest we're not looking in the right way. alien technology might be so advanced it's indistinguishable from natural phenomena, or it operates on scales we can't perceive, like quantum communication or dark matter engineering. But perhaps the most unsettling possibility is that we're truly alone, that in all this vastness, against all odds, Earth is the only place where life has not only arisen, but gazed up at the stars and wondered. The Fermi Paradox doesn't just ask where the aliens are, it forces us to question our own future. Are we destined to fade into silence, just another unmarked grave in the cosmic cemetery? Or is the universe waiting for us to become the ancient, advanced civilization others will one day search for? Until we know, the silence remains, and with it, a humbling reminder of how much we still don't understand. The cosmic microwave background is supposed to be the universe's baby picture, a near-perfect snapshot of the cosmos just 380,000 years after the Big Bang. Its faint glow evenly spread across the sky like static on an old television. But when scientists mapped this radiation with unprecedented precision, they found something that shouldn't be there, a bizarre alignment nicknamed the axis of evil. This isn't some cosmic conspiracy, it's a pattern so unsettling it makes physicists question whether the universe plays favorites. At first glance, the cosmic microwave background appears random, tiny temperature fluctuations no larger than 1/100th of a degree. But peel back the layers and anomalies emerge. The most shocking, the universe seems to have a preferred direction. Large-scale hot and cold spots align along a specific axis, as if space itself has a north and south pole. This flies in the face of cosmology's foundational principle, isotropy, the idea that the universe looks the same in all directions. The axis of evil isn't just an oddity, it's a direct challenge to the standard model of cosmology, the very framework we use to explain the universe's birth and evolution. Skeptics argue it could be a statistical fluke, a cosmic mirage created by the way we process data. After all, when you're analyzing something as subtle as temperature variations in primordial light, even tiny errors can create phantom patterns. But here's the problem: the axis of evil persists. Satellite after satellite, from WMAP to Planck, has detected this alignment, with odds of it being random as low as 1 in 10,000. It's like rolling a die 100 times and always getting a 6 eventually. You start questioning whether the die is loaded. The implications are staggering. If the universe isn't isotropic, our entire understanding of its origins might be missing a crucial piece. Some theorists propose exotic explanations, that we're seeing the gravitational imprint of a universe that existed before the Big Bang, or evidence of a multiverse tugging on ours like a hidden magnet. Others suggest the anomaly points to undiscovered physics, perhaps a flaw in Einstein's theory of gravity that only manifests on cosmic scales, but the most mind-bending possibility: that the axis of evil isn't a feature of the universe at all, but a shadow cast by something beyond it. Imagine standing in a room with walls painted to look like endless space, only to notice the brushstrokes all slant the same way. Could this alignment be a clue that our universe is finite, or that it's embedded in a higher dimensional structure we can't yet perceive? Until we solve this riddle, the axis of evil remains a cosmic thorn in our side, a reminder that the universe might not be as indifferent to direction as we once thought. In the vast tapestry of the cosmos, where galaxies cluster like cities in the night, there exists a place so empty, so unnervingly vacant, it feels like the universe forgot to fill it in. Welcome to the Boötes Void, a cosmic desert spanning 330 million light-years, where the expected glitter of galaxies is replaced by an almost unsettling darkness. Astronomers call it the Great Nothing, and for good reason. If you were to stand at its center, you'd see only a handful of galaxies in any direction, while a typical region of space that size should contain thousands. It's as if someone took a giant eraser to this patch of the universe, leaving behind a blank spot in the starry canvas. What makes this void so bizarre isn't just its size, it's the sheer improbability of its existence. According to our best models of cosmic structure, regions this empty simply shouldn't form naturally. The universe after the Big Bang was a nearly uniform soup of matter and energy. Over billions of years, gravity pulled matter into denser clumps, creating the web-like structure of galaxy clusters and filaments we see today. But the Boötes Void is a glaring exception, a hole in the cosmic web so vast it challenges our understanding of how matter distributes itself across space. One leading theory suggests the void might be the result of smaller voids merging over time, like soap bubbles combining into one giant empty pocket. Another, more speculative idea posits that it could be evidence of a collision with another universe, a cosmic bruise left behind by a reality beyond our own. Then there's the eerie possibility that the void isn't empty at all, but filled with something we can't see. Dark energy, the mysterious force accelerating the universe's expansion, might be concentrated here, pushing matter away and leaving behind this unimaginable emptiness. The few galaxies that do call the Boötes Void home only deepen the mystery. These isolated outposts, like lone survivors in a wasteland, are oddly quiet, lacking the vibrant star formation or violent collisions seen in denser regions. It's as if the void has sapped their vitality, leaving them frozen in time. Some researchers speculate these galaxies might be relics, ancient survivors from an earlier era, untouched by the chaotic interactions that shaped the rest of the universe. Yet for all its strangeness, the Boötes Void isn't entirely unique. Other large voids exist, though none as strikingly empty. What sets it apart is the sheer scale of its nothingness, a cosmic anomaly that forces us to confront how little we truly understand about the universe's architecture. Is it a statistical fluke, a natural outlier in an otherwise predictable cosmos? Or is it a clue, a signpost pointing to physics we haven't yet discovered? The void's silence is deafening. In a universe teeming with light and motion, this vast expanse of near-nothingness stands as a humbling reminder that even in our most detailed maps of the cosmos, there are still uncharted territories, places where the rules, it seems, don't apply. Until we unravel its secrets, the Boötes Void will remain one of space's most profound enigmas, a great nothing that somehow tells us everything about how much we have yet to learn. In 1972 and 1973, NASA launched two robotic explorers into the solar system, Pioneer 10 and Pioneer 11. These spacecraft were trailblazers, the first to venture beyond the asteroid belt, the first to visit Jupiter and Saturn, and the first human-made objects destined to drift endlessly among the stars. But as they sped toward interstellar space, something strange happened. Mission controllers noticed the probes were slowing down, just a fraction of a nanometer per second squared, a deceleration so slight it was like a single grain of sand gently pressing against a speeding car. Yet this tiny discrepancy defied all predictions. According to Newton's laws and Einstein's relativity, the pioneers should have been coasting flawlessly, their trajectories as predictable as clockwork. Instead, they were experiencing a mysterious drag, as if space itself had a faint, invisible friction. At first, scientists dismissed it as a glitch, perhaps a fuel leak or a software error. But as years turned into decades, the anomaly persisted. By the time the probes were billions of miles from Earth, their unplanned slowdown had added up, putting them hundreds of kilometers off course. The discrepancy became impossible to ignore. Dubbed the Pioneer Anomaly, it sparked a firestorm of speculation. Could this be evidence of undiscovered physics, a flaw in our understanding of gravity? Some theorists proposed exotic explanations, hidden dimensions subtly altering the fabric of space-time, or the gravitational pull of unseen dark matter clumped along the probe's path. Others wondered if Einstein's theory of general relativity needed tweaking at cosmic scales. Then came the mundane, but no less fascinating solution. After years of painstaking analysis, researchers concluded the anomaly might have a far simpler cause: heat. The Pioneer's nuclear power sources emitted a faint but steady trickle of thermal radiation, and because of the spacecraft's unique design, with dish-shaped antennas pointed back toward Earth, this heat could have bounced off their surfaces unevenly, creating a tiny but constant push in the opposite direction. Think of it like a flashlight in space. If you shine it backward, the photons carrying that light exert a minuscule recoil, a phenomenon called the Yarkovsky effect. The math seemed to fit, and by 2012, most of the scientific community accepted this explanation. Yet even today, some researchers remain unconvinced. The thermal model explains most but not all of the anomaly. A stubborn fraction of the deceleration remains unaccounted for, leaving the door cracked open for more radical possibilities. Could there still be undiscovered forces at work in the depths of space? The Pioneer's journey reminds us that sometimes the smallest mysteries can shake the foundations of science. These probes, now silent and drifting in the void, might still carry secrets, whispers of physics we've yet to uncover, waiting for another mission, another generation of explorers to decode their message. In the silent expanse above our planet, something unexpected may have been watching us for far longer than we realize, or so the story goes. Meet the Black Knight satellite, a legendary object said to orbit Earth, its origins shrouded in mystery and controversy. For decades, conspiracy theorists have claimed this enigmatic presence is no ordinary piece of space junk, but an ancient alien artifact, perhaps a relic from an advanced civilization, silently observing humanity's ascent. The tale begins in the late 1950s, when amateur radio operators reported picking up strange, delayed echoes of their own transmissions, as if something unseen in orbit was bouncing signals back. Then came the grainy photographs, dark, irregular shapes captured by early space missions, floating against the backdrop of Earth. Skeptics, of course, have a simpler explanation. The Black Knight, they argue, is likely a thermal blanket lost during a NASA spacewalk, or a discarded piece of a defunct satellite catching the light at odd angles. Even the famous echoes could be attributed to natural ionospheric phenomena, quirks of radio wave propagation that mimic artificial signals. But here's where the plot thickens. In 1998, astronauts aboard the space shuttle Endeavour photographed an unidentified object during a mission to assemble the International Space Station. The image, later released by NASA, shows a jagged silhouette drifting against the curvature of Earth, fueling fresh speculation. Was this the Black Knight finally caught on camera? Or just another mundane fragment of human-made debris? The intrigue doesn't stop there. Some researchers point to even earlier accounts, including claims that Nikola Tesla intercepted mysterious radio pulses in the 1890s, which he speculated might be attempts at extraterrestrial communication. Then there's the lore of ancient civilizations, stories of celestial visitors and sky gods, reinterpreted by modern mythmakers as potential evidence of the Black Knight's millennia-long vigil. Could it be a messenger, a sentinel, or simply a cosmic coincidence? What makes the Black Knight so enduring isn't just the mystery of its existence, but the larger questions it forces us to confront. In an era where thousands of satellites clutter Earth's orbit, how would we even recognize an artifact that wasn't ours? If an alien probe were hiding in plain sight, would we dismiss it as space junk, or would we dare to consider the impossible? The black night lingers in our collective imagination precisely because it exists in that liminal space between fact and folklore, a shadow we can't quite shake, a whisper we can't fully decipher. Whether it's a discarded piece of human ingenuity or something far stranger, one thing is certain. The legend of the Black Knight challenges us to look up and wonder what else might be out there, watching, waiting, just beyond the edge of our understanding. We think we know what the universe is made of: protons, neutrons, electrons, the stuff that builds stars, planets, and even us. But here's the cosmic twist. When astronomers tally up all the ordinary matter, or baryons, that should exist based on the Big Bang's aftermath, nearly half of it has gone missing. That's right, somewhere between the galaxies, in the vast stretches of seemingly empty space, an enormous amount of matter has slipped through our observational nets. This isn't dark matter, that mysterious invisible substance we've heard so much about. This is the regular, run-of-the-mill matter that makes up everything we can see and touch, and yet it's playing the ultimate game of hide and seek. For decades, this missing baryon problem gnawed at cosmologists. The math was clear: measurements of the cosmic microwave background, the afterglow of the Big Bang, told us exactly how much normal matter the universe should contain. But when we counted up all the stars, galaxies, and gas clouds we could detect, the numbers fell shockingly short. Where did the rest go? The answer, it turns out, might be hiding in plain sight, woven into the very fabric of the cosmos itself. Enter the cosmic web, the sprawling network of filaments that connects galaxies like beads on an invisible string. These threads, made mostly of ionized gas, are so diffuse and hot that they emit almost no light, rendering them nearly invisible to traditional telescopes. Think of it like trying to spot a single wisp of steam in a darkened room, only this steam is spread across millions of light years. Scientists now suspect these faint, intergalactic highways could be hiding the universe's missing matter, tucked away in a form so elusive it's taken us this long to even guess at its whereabouts. The hunt for these phantom baryons has led to some ingenious detective work. By studying how light from distant quasars filters through these filaments, astronomers have detected the faint fingerprints of ionized oxygen and hydrogen, telltale signs that the missing matter is indeed there, just in a form we struggle to observe. X-ray telescopes have also glimpsed hints of ultra-hot gas glowing faintly between galaxy clusters, like embers in the cosmic dark. Yet even with these clues, the full picture remains frustratingly blurry. The gas is so thinly spread, so scorchingly hot, that it slips past most of our instruments, leaving us with more questions than answers. Why does this matter, pun intended? Because without accounting for all the universe's normal matter, our understanding of cosmic evolution is fundamentally incomplete. These missing baryons aren't just a bookkeeping error. They're the raw material that shapes galaxies, fuels star formation, and ultimately makes life possible. If we can't trace their journey, we're missing a critical chapter in the story of how the universe grew from a fiery birth to the structured cosmos we see today. The mystery deepens when you consider the scale of the search. These filaments aren't just hard to detect, they're staggeringly large, often spanning hundreds of millions of light years. Mapping them requires stitching together observations from multiple telescopes, each sensitive to different wavelengths, like assembling a jigsaw puzzle where half the pieces are transparent. And even then, we might only be seeing a fraction of what's out there. Some theorists speculate that part of the missing matter could exist in an even more elusive state, perhaps as diffuse plasma laced with magnetic fields, or as low-energy particles that interact so weakly with light they're effectively invisible. What's thrilling is that we're on the cusp of breakthroughs. New instruments like the upcoming Athena X-ray Observatory promise to peer deeper into these intergalactic shadows, potentially revealing the hidden baryons in unprecedented detail. Until then, the missing matter problem stands as a humbling reminder that even the ordinary parts of the universe can defy our expectations. After all, if we're still struggling to account for the stuff we're made of, imagine how much more there is to discover about the cosmos' darker, more mysterious secrets. The cosmic microwave background is often described as the universe's baby picture, a near-perfect snapshot of its infancy. But when scientists scanned this ancient light, they stumbled upon something that shouldn't exist, a chilling, colossal blank spot in the constellation Eridanus. This isn't just a minor temperature fluctuation. It's a sprawling cold zone so vast it could fit thousands of galaxies, yet it's eerily empty. Dubbed the Eridanus Supervoid, this cosmic anomaly is more than just a curiosity. It's a direct challenge to our understanding of how the universe structures itself. At first glance, the cold spot might seem like a statistical fluke. After all, the cosmic microwave background is speckled with tiny variations, remnants of density fluctuations from the Big Bang. But the Eridanus anomaly is different. It's colder than its surroundings by about 70 microkelvin, a subtle difference, but one that spans an area nearly 2 billion light-years across. To put that in perspective, if our Milky Way were a grain of sand, the supervoid would be the size of a football stadium, and according to standard cosmology, voids this large simply shouldn't exist, let alone leave such a pronounced thermal imprint. So what could possibly explain this frigid expanse? One theory suggests it's a true supervoid, a region of space where matter is unusually sparse, causing light passing through it to lose energy, a phenomenon known as the integrated Sachs-Wolf effect. Imagine walking uphill for miles only to find the other side drops into a valley much deeper than expected. That's what photons from the cosmic microwave background experience when they traverse the supervoid, emerging slightly colder on the other side. But here's the catch: even the largest known voids can't fully account for the temperature drop observed. The math just doesn't add up. This discrepancy has led to more radical explanations. Some theorists propose the cold spot might be evidence of a collision with another universe, a bruise left by a cosmic sibling in the multiverse. In this scenario, our universe's space-time could have bumped against another bubble universe, draining energy from the contact zone and leaving behind this anomalous chill. Others speculate it could be a sign of exotic physics, like a defect in the fabric of space-time itself, a cosmic knot formed during the universe's earliest moments. Yet not everyone is convinced. Skeptics argue the supervoid might be an illusion, a trick of perspective caused by multiple smaller voids aligning along our line of sight. Or perhaps our models of how voids interact with light are incomplete, missing some subtle mechanism that amplifies their cooling effect. The debate rages on, but one thing is clear: the Eridanus supervoid refuses to fit neatly into any existing cosmological box. What makes this mystery so compelling isn't just its scale, it's the way it forces us to confront the limits of our knowledge. If the supervoid is real, it could mean our universe is far stranger, far more textured than we ever imagined. And if it's not, then we're left with an even more unsettling question. What else might we be missing in the vast, uncharted stretches of the cosmos? Until we solve this riddle, the Eridanus cold spot will remain a cosmic enigma, a silent, freezing reminder of how much we still have left to discover. On October 19, 2017, astronomers spotted something streaking through our solar system that shouldn't have been there, a visitor from the stars. Named Oumuamua, Hawaiian for scout or messenger, this mysterious object was the first confirmed interstellar traveler ever detected passing through our cosmic neighborhood. But what made it unforgettable wasn't just its origin, it was the way it behaved. Slingshotting past the sun at blistering speeds, Oumuamua defied all expectations. Most asteroids and comets follow predictable paths dictated by gravity, but this one had other plans. As it hurtled away, something gave it an unexpected push, accelerating it just enough to raise eyebrows across the scientific community. The anomalies didn't stop there. Oumuamua's shape was unlike anything we'd seen before, a bizarre, elongated cigar, roughly 10 times longer than it was wide, tumbling end over end through space. Natural objects tend to be lumpy or spherical, not needle-like. Then there was its brightness. As it rotated, its luminosity varied dramatically, suggesting an irregular, reflective surface, something more akin to polished metal than the dull, rocky veneer of typical asteroids. Even its color was odd, a deep red, similar to objects in the outer solar system, yet with no visible coma or tail, the hallmarks of an icy comet sublimating in sunlight. Theories swirled. Could it be a shard of a shattered planet, ejected from another star system? A rogue iceberg stripped of its volatile gases by eons of cosmic radiation? Or, as Harvard astrophysicist Avi Loeb controversially proposed, might it be something far more extraordinary, an artificial construct, perhaps a light sail or debris from an alien spacecraft? The idea wasn't entirely baseless. Oumuamua's acceleration matched what you'd expect from a thin, reflective object pushed by solar radiation, much like a sail catching the wind. But critics countered that outgassing hidden jets of gas from a comet's surface could explain the thrust even if we couldn't see them. The debate raged because Oumuamua left as abruptly as it arrived. By the time we noticed it, the object was already racing away, too distant for detailed observation. Our best telescopes caught only fleeting glimpses, leaving us with more questions than answers. Was it a cosmic iceberg venting invisible hydrogen as it warmed? A fractal-like dust aggregate, so porous it reflected light strangely? Or something else entirely, a fragment of a technology beyond our understanding? What makes Oumuamua so tantalizing isn't just its mystery, it's the precedent it set. Since its discovery, we've spotted more interstellar visitors, like the comet Borisov in 2019. But none have been quite like Oumuamua. Its peculiarities force us to confront an unsettling truth. The universe is far stranger than we imagined, and its messengers don't always fit the molds we've prepared for them. Whether natural or not, Oumuamua remains a cosmic postcard from the unknown, a single line in a conversation we're only beginning to hear, and the next time an interstellar guest arrives, we'll be watching, ready to listen. Imagine measuring the same room with two different rulers only to find they give you wildly different answers. That's essentially the crisis cosmologists are facing with the Hubble tension, a glaring mismatch in how fast the universe is expanding depending on which cosmic ruler you use. On one side, we have the ancient light of the cosmic microwave background, the afterglow of the Big Bang, suggesting an expansion rate of about 67 kilometers per second per megaparsec. On the other, measurements of nearby stars and supernova peg the number closer to 73, a difference that might seem small but carries universe-shattering implications. This isn't just a quirk of measurement error. The discrepancy persists even as our tools grow more precise, like a stubborn crack in the foundation of modern cosmology. If both methods are correct and there's no evidence either is flawed, then something fundamental in our understanding of physics must be missing, the most obvious suspect. Dark energy, the mysterious force accelerating the universe's expansion. Current models assume it's a constant and unchanging pressure woven into space-time itself. But what if it's not? What if dark energy evolves over time, growing stronger or weaker in ways we haven't accounted for? Then there's the more radical possibility that Einstein's theory of general relativity, the bedrock of cosmology, might need tweaking on cosmic scales. Imagine gravity itself behaves differently across vast distances, like a river that flows smoothly near its source but churns unpredictably as it widens. Some theorists propose modifications to gravity's equations, adding terms that only kick in over billions of light years. Others speculate we're seeing hints of extra dimensions or quantum effects warping spacetime in ways we can't yet model. The stakes couldn't be higher. Resolving the Hubble tension isn't just about fixing a number, it's about rewriting the cosmic rulebook. If dark energy isn't constant, it could mean the universe's fate is far stranger than we thought, perhaps destined for a big rip where galaxies, stars, and even atoms are torn apart. Alternatively, if gravity itself is the culprit, we might be on the verge of a paradigm shift as profound as relativity or quantum mechanics. For now, the tension remains a puzzle at the heart of modern physics. New telescopes like the James Webb Space Telescope and next-generation observatories are joining the hunt, scrutinizing the universe with unprecedented precision. Whatever they find, whether a subtle flaw in our measurements or a revolution in physics, one thing is certain: the cosmos still has surprises up its sleeve, and the Hubble tension is our front row seat to the unraveling. Deep in the heart of our galaxy, where stars crowd so thickly they blur into a golden haze, there's a glow that shouldn't exist, a persistent, enigmatic hum of gamma rays radiating from the Milky Way's core. Astronomers call it the galactic center excess, and it's one of the most stubborn puzzles in modern astrophysics. Imagine standing in a pitch-black forest, only to notice a faint, eerie light emanating from the ground beneath your feet. No flashlight, no fire, just an unexplained radiance seeping from nowhere. That's the essence of this cosmic conundrum, an energy signature with no obvious source, defying every conventional explanation we've thrown at it. The mystery began when NASA, a Fermi Gamma-ray space telescope, mapped the galaxy's high-energy emissions, revealing an unexpected surplus of gamma rays concentrated within about 5,000 light-years of the galactic center. At first glance, you'd expect such radiation from known objects, pulsars, black holes, or the remnants of supernova. But here's the twist: when scientists subtracted all those familiar sources from the data, the glow remained, like a ghostly afterimage burned into the cosmic canvas. The excess doesn't match the profile of any known astrophysical process. It's too smooth, too evenly distributed, as if the core of our galaxy is bathed in a uniform, invisible fire. One tantalizing theory points to dark matter, the elusive substance that makes up 85% of the universe's mass. Some models suggest dark matter particles could annihilate when they collide, converting their mass into energy and producing gamma rays as a byproduct. If true, the galactic center excess might be our first direct glimpse of this shadowy component of reality, a cosmic fingerprint left by particles we've never seen. The galaxy's core, with its dense gravitational field, would be the perfect place for such interactions to occur. But there's a catch: the energy signature doesn't perfectly match predictions. The gamma rays are slightly softer, lower in energy than most dark matter models anticipated, leaving scientists scrambling to adjust their equations or consider alternatives. Then there's the pulsar hypothesis. Millisecond pulsars rapidly spinning neutron stars emit gamma rays, and the galactic center is teeming with them. Could a population of faint, unresolved pulsars be mimicking the smooth glow we observe? It's possible, but here's the problem: we'd need an implausibly large number of these objects to account for the excess, far more than current surveys suggest exist. Even more puzzling, the glow extends farther from the galactic plane than pulsars typically do, as if the excess refuses to conform to any tidy explanation. The plot thickens when you consider the excess isn't alone. Similar gamma-ray glows have been detected in dwarf galaxies orbiting the Milky Way, and strangely, even from the direction of our solar system's north and south poles. Are these connected phenomena or just cosmic coincidences? Some researchers speculate we might be seeing evidence of a previously unknown astrophysical process, something beyond our current catalog of high-energy events. Could it be exotic stellar interactions, rogue black holes, or even the decay of primordial particles left over from the Big Bang? What makes this mystery so thrilling is that it's a detective story unfolding in real time. Every new observation, every tweak to our models brings us closer to an answer, or deeper into the labyrinth. The galactic center excess isn't just a scientific curiosity, it's a beacon illuminating the gaps in our understanding of the universe's most fundamental workings. Whether it's dark matter's long-awaited reveal or something entirely unexpected, one thing is clear: the heart of our galaxy holds secrets we've only begun to unravel. And until we solve them, that unexplained glow will keep drawing us back, a siren song written in gamma rays. Most cosmic structures are chaotic exploding stars scattering debris like shrapnel, galaxies colliding in messy spirals, nebulae stretching into organic, cloud-like formations. But hovering 5,000 light-years away in the constellation Monoceros, there's a cosmic rebel that breaks all the rules, the Red Rectangle Nebula. This isn't your average stellar spectacle. Through a telescope, it appears as a near-perfect geometric figure, a glowing, crimson-hued X-shape framed by what looks like the precise lines of a celestial drafting tool. It's so unnervingly symmetrical that early astronomers suspected an optical illusion, a trick of perspective. Yet the more we studied it, the stranger it became. At the heart of this cosmic artwork lies HD 44179, a dying binary star system. As these stars shed their outer layers, they've sculpted the nebula's distinctive shape. But here's the catch: no known stellar process should create such razor-sharp angles. Most planetary nebulae bubble outward in delicate spheres or intricate, asymmetrical tendrils. The red rectangle's rigid structure defies that expectation, as if nature traded its usual paintbrush for a straight edge and protractor. Even more puzzling is its color. The deep red hue comes from a rare form of carbon-rich molecules called polycyclic aromatic hydrocarbons, which fluoresce under starlight like neon signs in a cosmic alleyway. These molecules shouldn't survive here, in the violent outflow of a dying star, yet they're thriving, painting the nebula in hues unlike anything else in the known universe. The leading theory suggests the binary star's orbital dance is the architect. As one star exhausts its fuel and expels gas, its companion star's gravity funnels that material into twin conical jets, carving the nebula's iconic X-shape. But simulations struggle to replicate the rectangle's crisp edges. Real-world physics tends to blur such precision. Some researchers propose the presence of an unseen disk, a dense ring of dust and gas acting like a stencil, shaping the outflow into geometric perfection. Others wonder if we're witnessing a new class of stellar death, where magnetic fields or exotic chemistry play unexpected roles. Then there's the mystery of the ladder rungs. High-resolution images reveal faint, evenly spaced horizontal bars crossing the nebula's arms, resembling a celestial etch-a-sketch. These periodic structures, seen nowhere else in nature, suggest rhythmic pulses of material ejected at regular intervals like a stellar heartbeat recorded in gas and dust. What cosmic metronome could keep such perfect time? The answer might lie in the star's precise orbital cycle, or perhaps something more exotic, like resonant vibrations in the surrounding dust cloud. The Red Rectangle challenges more than just our understanding of stellar mechanics. It forces us to reconsider how beauty emerges in the cosmos. We're accustomed to finding symmetry in living things, the spiral of a nautilus shell, the fractal branches of a tree. But here, in the cold vacuum of space, geometry arises from chaos, as if the universe itself has an aesthetic we're only beginning to appreciate. Whether it's the handiwork of hidden physics or a fleeting alignment of stellar conditions, one thing is certain: this crimson enigma reminds us that even in death, stars can create art beyond our wildest imagination. And somewhere in its precise angles and glowing rungs, there might be clues to processes we've yet to dream of. The universe is supposed to be expanding uniformly, with galaxies drifting apart like raisins in rising bread dough, except some aren't playing by those rules. In the early 2000s, astronomers poring over data from the Wilkinson microwave anisotropy probe stumbled onto something unsettling. Certain galaxy clusters, thousands of them, weren't just moving with the cosmic expansion. They were streaming in the same direction at breakneck speeds, as if drawn by an invisible current. This phenomenon, dubbed the dark flow, suggests something massive and unseen, far beyond the edges of our observable universe, is tugging at the fabric of reality itself. What makes this discovery so unnerving is the scale of the motion. These aren't just a few rogue galaxies meandering off course. We're talking about entire clusters, each containing hundreds or even thousands of galaxies, all being pulled toward a single patch of sky near the constellations Centaurus and Vela. Their collective velocity is staggering. Some estimates suggest they're racing at nearly 2 million miles per hour, a movement that can't be explained by the gravitational pull of any known structure in our cosmic neighborhood. Even the Great Attractor, that mysterious gravitational anomaly we discussed earlier, pales in comparison to whatever's causing this. Theories about the dark flow's origin range from the mind bending to the outright revolutionary. One possibility is that it's evidence of a supermassive structure lurking in the unobservable universe, a region of space so distant its light hasn't had time to reach us since the Big Bang. Picture a cosmic neighbor so colossal its gravity leaks into our observable bubble, warping the motion of galaxies like a magnet tugging at iron filings. Another, even wilder idea is that we're seeing the gravitational imprint of another universe entirely, a sibling cosmos in the multiverse brushing against our own, its presence felt only through this ghostly tug on our galaxies. Skeptics argue the dark flow might be an illusion, a statistical fluke or a systematic error in how we measure galaxy motions, but the signal has persisted across multiple studies, even as our observational tools have grown sharper. The Planck satellite, designed to map the cosmic microwave background with unprecedented precision, detected hints of the same large-scale flow, adding weight to the mystery. If it's real, the implications are profound. Our standard model of cosmology assumes the universe is isotropic, the same in all directions on the largest scales. The dark flow challenges that assumption, suggesting there's a preferred direction woven into the cosmos, a cosmic bias that defies our understanding of how space-time should behave. Perhaps the most tantalizing clue lies in the flow's alignment with the so-called axis of evil, that mysterious cosmic microwave background anomaly we covered earlier. Both point toward the same general region of space, hinting at a connection between these two enigmas. Could they be different facets of the same underlying phenomenon, a fundamental lopsidedness in the universe's structure? Or are we seeing the first cracks in our cosmological models, signs that gravity or dark energy operate differently on scales we're only beginning to probe? The dark flow forces us to confront a humbling possibility that what we call the universe might just be a tiny fraction of something far grander. Beyond the cosmic horizon, past the limits of what our telescopes can see, there could be structures, forces, even entire realms of existence that shape our reality in ways we've only begun to glimpse. Until we unravel this mystery, the dark flow will remain one of cosmology's most provocative puzzles, a silent current in the cosmic dark, pulling us toward questions we're not yet equipped to answer. Imagine a world where mountains aren't made of rock, but of diamond, where the very ground beneath your feet glitters with crystallized carbon, forged under pressures so extreme they defy earthly logic. Meet PSR J1719-1438b, an exotic planet orbiting a pulsar 2,000 light-years away, and one of the most bizarre objects ever discovered in the cosmos. This isn't just a planet with diamond deposits, it's a celestial body scientists believe could be made of the stuff, a cosmic jewel so dense and strange it rewrites the rules of planetary formation. The story begins with its parent star, a millisecond pulsar, the rapidly spinning corpse of a massive star that went supernova. These stellar zombies emit beams of radiation like cosmic lighthouses, and it was during routine observations of this pulsar's rhythmic pulses that astronomers noticed something odd. The timing of the pulses wobbled slightly, a telltale sign of an orbiting companion tugging at the star, but when they calculated the companion's mass, they got a shock. This wasn't another star or a run-of-the-mill gas giant. It was something far more peculiar, a planet roughly the size of Jupiter, yet with 40% more mass crammed into the same volume. That kind of density suggested an object unlike anything in our solar system. Here's where the diamond theory comes in. Under normal circumstances, a planet this massive would be a gas giant, but PSR J1719-1438b orbits so close to its pulsar that any atmosphere would have been stripped away long ago, leaving behind a bare, ultra-dense core. Based on its composition and the crushing gravitational forces at play, scientists speculate that the planet's carbon-rich interior, subjected to pressures millions of times greater than Earth's, may have crystallized into diamond. Picture a world where the carbon atoms, instead of forming graphite or other familiar structures, align into a rigid, planet-sized lattice of gemstone. But the mysteries don't stop there. How did such a planet even form? One leading hypothesis suggests it might be the corpse of a white dwarf, a dead star that once orbited the pulsar. Over time, the pulsar's gravity could have siphoned away the white dwarf's outer layers, leaving behind a carbon-oxygen core compressed into a diamond-like state. It's as if the universe took a dying star and forged it into the ultimate cosmic heirloom. The implications are staggering. If planets like this exist, they hint at a hidden diversity of worlds far beyond the rocky planets and gas giants we're familiar with. What other exotic forms might planets take under such extreme conditions? Could there be worlds of solid metallic hydrogen or oceans of liquid diamond? PSR J1719-1438b challenges us to rethink the boundaries of planetary science, proving once again that the universe's creativity outpaces our wildest imaginations. And while we'll never walk on its diamond-crusted surface, its very existence is a glittering reminder of the endless wonders waiting to be uncovered in the cosmos. Even the universe has its giant structures so vast they make entire galaxy clusters look like specks of dust. The Hercules corona Borealis Great Wall is one such colossus, a sprawling filament of galaxies stretching over 10 billion light-years, a structure so immense it defies the very laws we thought governed cosmic architecture. Picture this: if our Milky Way were the size of a grape, this Great Wall would span the width of the continental United States. Its sheer scale is staggering, but what truly rattles scientists isn't just its size, it's the fact that it shouldn't exist at all. The cosmological principle, a cornerstone of modern astronomy, states that on the largest scales, the universe should look roughly the same no matter where you're observing from. Matter ought to be evenly distributed, like sprinkles mixed into cake batter. Yet the Hercules Corona Borealis Great Wall shatters that assumption. This isn't just a slight clustering of galaxies. It's a titanic, thread-like structure, a cosmic skeleton that challenges our understanding of how the universe organizes itself. The odds of such a formation arising naturally in the time since the Big Bang are vanishingly slim, like rolling a die 1,000,000 times and getting the same number every single time. So how did this monstrosity come to be? One possibility is that it's a relic of the universe's infancy, a fossilized imprint of primordial density fluctuations that somehow survived cosmic expansion. In the chaotic aftermath of the Big Bang, tiny quantum ripples in spacetime could have seeded regions where matter clumped more densely, eventually snowballing into this unimaginably vast wall. But even this explanation strains credibility. Simulations of the early universe struggle to produce structures of this scale, leaving theorists scrambling for alternatives. Could there have been exotic forces at play in the cosmos's first moments, something beyond our current models of inflation or dark energy? The discovery also forces us to confront an unsettling question. Is this wall unique, or are there others like it lurking in the unseen reaches of space? Our telescopes can only peer so far, limited by the age of the universe and the speed of light. What if the Hercules Corona Borealis Great Wall is just the first of many such behemoths, hidden beyond our observational horizon? Some researchers speculate that these structures might be interconnected, part of a cosmic web even more intricate and unbalanced than we've imagined. What's at stake here isn't just a record-breaking celestial formation, it's the foundation of cosmology itself. If the universe isn't as uniform as we thought, entire chapters of astrophysics might need rewriting. Dark energy's role, the fate of cosmic expansion, even the nature of gravity itself could be called into question. The Hercules Corona Borealis Great Wall isn't just a curiosity. It's a crack in the edifice of our understanding, a silent challenge from the cosmos to look deeper, think harder, and admit that even our grandest theories might still be playing catch-up with reality. And until we solve its riddle, this galactic leviathan will loom over astronomy, a reminder that the universe reserves its greatest surprises for those who dare to map its unexplored edges. The James Webb Space Telescope was supposed to bring the early universe into focus, to show us the first flickering lights in the cosmic dark. Instead, it handed us a paradox. Peering back over 13 billion years to a time when the universe was barely 5% of its current age, JWST found galaxies so massive, so fully formed, they shouldn't exist. These cosmic titans, some weighing in at 10 times the mass of our Milky Way, appear to have matured at breakneck speed, assembling themselves in what seems like the blink of an eye on the cosmic timescale. It's like finding a skyscraper in the middle of what should be barren wilderness, with no blueprints or construction crews in sight. The problem isn't just their size, it's their sophistication. These early galaxies aren't just clumps of young stars. They're structured with distinct features like disks and spiral arms, and they're already rich with heavy elements forged in stellar furnaces. Under current models, that's impossible. Galaxies need time to grow, gravity slowly pulling together gas and dust over billions of years. Stars must live, die, and explode, scattering the metals that seed future generations of stars and planets. Yet here they are, these fully fledged galactic metropolises, thriving when the universe was still in its infancy. Cosmologists are scrambling for explanations. One possibility is that our understanding of galaxy formation is fundamentally incomplete. maybe the early universe had denser pockets of dark matter, accelerating the birth of galaxies in ways our simulations don't account for. Or perhaps star formation in these primordial environments was wildly more efficient, with gas collapsing into stars at rates we've never observed in the modern cosmos. Some theorists are even revisiting exotic ideas like primordial black holes, ancient relics from the Big Bang that could have acted as gravitational anchors, jump-starting galaxy growth. Then there's the more radical alternative. What if our cosmic timeline is wrong? The age of the universe is pinned to the Hubble constant, the rate at which space is expanding. But if that measurement is off, if the universe is actually older than we think it might buy these galaxies the extra time they seem to demand, the catch. Tweaking the Hubble constant would send shockwaves through cosmology, forcing us to rethink everything from the nature of dark energy to the very timing of the Big Bang. But here's the twist that really keeps astronomers up at night. Some of these galaxies appear to be too red. In astronomy, color often indicates age. Older stars glow redder as they cool. Yet these galaxies are so ancient that their redness suggests stars formed even earlier, pushing the limits of cosmic possibility. It's as if we've uncovered ruins older than the civilization that supposedly built them. This isn't just an academic puzzle. These galactic anomalies are cosmic stress tests, probing the limits of our best theories. If standard models can't explain them, we might be on the verge of uncovering new physics, rules that govern the universe in its extreme youth but faded from view as the cosmos aged. Or perhaps we're seeing the fingerprints of something even stranger, a chapter of cosmic history written in laws we haven't yet imagined. Every time JWST points its golden mirror deeper into the past, it risks finding more of these impossible galaxies, each one a silent challenge to our understanding of how the universe works. And until we solve their riddle, they'll stand as monuments to the humbling truth that the cosmos still holds mysteries too profound for even our most advanced tools to easily unravel. From the haunting silence of the Fermi Paradox to the unnerving geometry of the Red Rectangle Nebula, these 20 cosmic anomalies aren't just scientific curiosities. They're humbling reminders of how much the universe still keeps hidden. Every flicker of an unexplained signal, every gravitational tug from the unseen, forces us to confront the limits of our understanding, and that's precisely what makes them so thrilling. These aren't dead-end puzzles, they're doorways, each one inviting us to step beyond the known and imagine what might lie on the other side. Think about it, every anomaly we've explored today started as a blip in the data, a nagging inconsistency that refused to fit the mold. The wow signal, the Great Attractor, the impossible galaxies, they all began as outliers, anomalies that could have been dismissed as noise, but because scientists dared to ask, what if? We now have entire fields of research dedicated to unraveling their secrets. The mysteries of today are the breakthroughs of tomorrow. Dark matter, once a fringe hypothesis, is now a cornerstone of cosmology. Fast radio bursts, once written off as equipment glitches, might soon revolutionize how we map the universe's hidden structures. What's truly extraordinary is how these cosmic riddles connect. The same void that makes us question the distribution of matter might hold clues to dark energy. The same anomalies in galaxy formation could reshape our understanding of the Big Bang. It's as if the universe is whispering a single, sprawling story, and we're only just learning to listen. And with tools like the James Webb Space Telescope and next-generation gravitational wave detectors, we're gaining the vocabulary to translate those whispers. But here's the most beautiful part. You don't need a telescope to be part of this journey. Every time someone looks up at the night sky and wonders, every time a curious mind questions an accepted theory, the exploration continues. Maybe the next great cosmic revelation will come from a backyard astronomer, a grad student crunching data, or even a YouTube comment sparking an unexpected idea. So tell us which of these 20 anomalies left you awestruck: the eerie precision of the wow signal, the cosmic betrayal of the dark flow, or something else entirely. Drop your thoughts below, and if you're hungry for more universe-shaking mysteries, hit that subscribe button, because the cosmos isn't done surprising us. For every question we answer, a dozen more emerge, and the next great enigma could be discovered tomorrow. The universe is vast, strange, and endlessly generous with its puzzles. All we have to do is